Welcome back everyone. Day two. Today I guess this is going to be the third session of week 7. Yes, the second day in the third session. So I will just share my screen and we can start the presentation. Also, meanwhile, we can wait for more people to join for I guess 2 minutes. Yeah, let's just wait for 2 more minutes for other people to join. So yeah. Um, yeah, just we could have started the recording now. So yeah, let me just share my screen. And am I audible? You can hear my voice, right? Thank you, Stefano Sadisu. Thank you, everyone. So today we're going to focus on detection. There's going to be very little of the notes or the concept. So the session will be about introduction to data enrichment and YOLO, mainly how can we enrich our data or the content of our data using animates or using this kind of computer vision tools. So like the idea of computer vision detecting animates and things like that, they came from the in order to take some images and graphical things as a data, computer vision was one of the tools for like increasing our data and using more data for whatever we're using the data for. So what is the power of imaging data? Because we already know what the power of data, and the more data that we have, and the more clear and neat data that we have, the more powerful is our engine or our pipeline that we're going to build. So, for example, in our case, if we're going to you guys are going to scrape. By now, you might already scrape data from your Telegram. So the Telegram image might include pills, creams, and different type of image or medical equipment. So image contains rich and unstructured information critical for deeper insights. So like you might want to identify specific type of drug. Also, there are different type of machine learning tools or machine learning algorithms that are being used on agriculture, like being able to identify which potato or which fruit or which veggie is infected, trying to detect the type of coffee. There are different type of machine learning algorithms and machine learning projects that are then based on this agricultural, actually for the agricultural sector. So this type of sectors or this type of functionality of the machine learning, they need their data that they're going to be trained on. They need the data to be in an image form. Okay, so there are simple and like complicated form of computer visions, also machine learning models. Like maybe if you've heard of it, like the convolutional neural network. That is, we're going to use that type of model for, like, for training image and things like that. But for in the simplified form, in the simplified image detection, or to build that type of powerful pipeline, the base model that we're going to use or is YOLO. It's one of the models. We're going to go to that, but so there are this type of different type of projects, and imaging or detecting images a useful aspect of some machine learning projects. So what is data enrichment? It's adding new valuable information to existing data or to the data that we already have, right? In this case, augmenting Telegram message data with visual insights from images. So augmenting, by augmenting means just you have one data or you have specific number of data, trying to reuse that for different purpose or in a different value. Say it might be changing the direction or changing the size, or rotating the image is also, if it is an image, is also considered as augmenting. So in this case, augmenting the Telegram message data with visual insights from image is going to be one of the data enrichment that you guys are going to make. And the other is transform raw observation into actionable intelligence, or yeah, which is like just an image into how can we use this image for us as an input, or as an input for our model, or as an input as a data for our model training. So what is YOLO? YOLO is you only look once. YOLO means like it's an abbreviation that stands for the same things, and it's state of the art object detection model. So it's by itself model. I mean, YOLO by itself is a model that is used to detect objects. It's fast and accurate, which is ideal for processing large volumes of image, and it identifies what objects are in an image and where they are. Like there is three different or three main things that YOLO model we're going to detect. So whatever the image, the given image is, it will try to detect the bounding box, the class label, and the confidence score. The bounding box means like, let's start from the class. The class means what a specific object stands for. Is this a car? Is this a house? Is this a pencil? That is the class label. So mainly when you like when you so already by itself I've told you that YOLO is a model, right? So when the model is built, so it has its own class labels that would classify things to parts, to many different parts. So it might not be for a specific target, you might want to fine tune, or for you might need to fine tune it or to train it. But specifically, there are lots of data that the model itself is trained on. So it will classify those objects into different classes. And the other is the bounding box, which is, so now we have a class. So in which area or in which specific space is that class appearing. Okay, so it would bound them in a box, and that is called a bounding box. In the confidence score, so we're predicting or we're classifying an object to a specific to a particular class, right? So in what confidence, or what is it's more of an accuracy. In model training we call it an accuracy, right? We're 0.9% sure and things like that. So the confidence score in YOLO is what percent of our prediction do the model feel like this is the correct type of labeling or prediction. So these are the three main identifiers or part of these are the three main components of YOLO. So the key benefit for us is it automates the extraction of visual product information. So we can just automatically extract the visual product information. So why would we use YOLO, specifically YOLO V8? So efficiency, process many images quickly. So we can leverage pre-existing models trained on vast dataset, like Coco is the dataset that the YOLO model is trained on. So we can leverage the pre-existing models to detect common objects. Then we can potentially fine-tune for specific medical products if needed. So in this way, we are going to deal with medical products. So it is just as a recommendation. If it is not going to work for you it is going to work actually, but you can just directly use YOLO. But if you need a detailed or more advanced use from your from YOLO, so you can just fine tune the model by using the data that you already have, and by you also can hypertune. So you can change it's just a free model, so you can change some feature of the model so that you can make it specifically to focus on one specific area, in this case the medical area. And it's a Python library, which is Alpha Analytics, makes it easy to integrate into our data pipeline or in every data pipeline. So it is easy for integration, its efficiency, and its the ability of bringing YOLO or fine-tuning YOLO and adapting it to a specific scenario or domain will make us to choose YOLO. So you can just see that YOLO is Unicorns, the V8 is the version 8. So recently it was version 5, now it's version 8. I guess it's also, we've reached version 11. Okay, so you can use whatever version that you want. So the model is being improved, so the number will continue, but the main idea and the main concept is not going to change. This is going to be the main concept. So what is going to be the purpose of YOLO in our ELT pipeline? Because now we're extracting, loading, and transforming data, right? So in this big project, it's more of an ELT project. So we have the raw data like image, and then using YOLO V8, we're going to make an object detection, which is we're going to have some script for that, and then the detected object we can just convert. So now we have just an image, right? So we can just extract the detection of the image, the detection data that we have made for the image, and we can convert that data to JSON or CSV as you want, because I guess you guys are supposed to put the data in your database. So and you can make some DBT transformation. So you're going to see DBT in the other end, and then finally you're going to load it to your database. So you're going to see the DBT part and in another sessions. But it's going, since so now you have extracted data, you've extracted data from Telegram, and you're going to extract data from your image, and that is the extraction part. The loading part will be uh, putting it in your database. The transformation part here in DBT, you're going to learn some transformation logic, how to put the data and how to organize it. So that are the main three concepts. So you're going to apply the ALT both for your data that you've scraped from Telegram, and then for the image. So the enrichment process in our ALT is going to be extracting, which is images are scraped from Telegram channels and stored in our raw data lake. And YOLO processing, which is the dedicated script, will scan for new image in the data lake, and it will load the trained YOLO V8 models and run inference on each image to detect objects. So every image needs to be inferred, and then every image needs to be detected if there is any information that we want to include. And then you will load or detect objections, so that it takes your results, which is object, class, config. I have told you that the three main things that we're going to detect in using YOLO is the class, the confidence score, and the bounding box coordinates. So you can just store those information. This could be in a JSON or in a CSV format, and then you'll apply transformation or using DBT. So you will just be familiar with DBT soon, and then you can use a new DBT model, and then you can this will take place for detection results. It will clean, structure, and standardize the data based on your need. And crucially, it will link face detection back to our FCT image, which is the model that we're going to create using message ID. Again, this is not, you don't need to worry about this part. And the main point is you enable queries like show me all messages with image containing pics and their associated channels. So now we have just a message ID, or we have just a specific ID that will tell something about that specific image. So we can just query the data, as the same goes for as we can query the database for some sentence or for some another word related data. We can just query for the image too, and then we'll expose it through our API. So this will just, I just wanted to make sure in this part. So this is because this is how we're going to enrich our data, or enrich the data source that we have for all our pipeline and for the model. Okay, so this is going to be the process that you guys are going to apply. Okay, so Let me present another thing. So it is visible, right? If it is not visible, then yes. Speak up, okay, thank you. So the first thing to do is installing the libraries, which is Ultralytics library in the OpenCV Python library that we have mentioned earlier. This who owns the yellow lead. So we need to install this library here. Also, you can just do it from your terminal. Okay. So as I've told you, there is the YOLO. There are different versions of YOLO, right? YOLO V8, YOLO V5, YOLO V5, YOLO V8. Now it is YOLO version 11 almost. So you can see that here I have the. Before that, I have just some data here. Image one, image. Let's see what they look like. We have the cut here. We have this data here. So we have these three data, okay? So we're just trying to make some, we're not trying to see for some specific thing, but we're just trying to detect whatever there is in the picture. So let's go back to our notebook actually. So the first thing to do is now we have after installing this library, Ultralytics library, we will import the Ultralytics CV2, which is the computer vision library, and whatever is important or whatever is needed. And then you can just run your model or uh, you need to download and run your model. Okay, here. So from here, we have imported specifically from Analytics YOLO. That is as easy as this. So from the model, you need to load from YOLO, specifically YOLO version 8 in. So there are different type of, so in will indicate to nano. There is the nano, there's the small, large, still in version 8. Okay, there are different part of YOLO V8 version. So specifically, I have loaded the V8 in. Library. So actually it's already loaded. I've just run this. So you have this is just a print message. So this will indicate this is giving us the information for the model. It have 129 layers. It has 3,100. I mean 3,157,200 parameters, zero gradients, and 8.9 J loops. So this is telling us. So I have told you it is a model by itself. So it is trained and things like that. So it is trying to tell us the information about the model itself. So while you're going to fine tune the model, so you're going to start from this information, right? From 1 to 9 layers and from these parameters. And maybe you want to increase it, you want to decrease it, you want to do some other stuff. So this is your basic information. So here is the image directory, which is the image one, image two, image three. I have already loaded the image here, and this is the result directory that we want to see the result on. So for now, let me delete the result so that we can see it again. So here, if the result directory is not there, it is going to create the specific directory. So this will help us if the image file, we're trying to accept every type of image file, JPG, PNG, and anything, okay? So let's run this again. So it is trying to find out if we have an image on the specific path. So we have found 3 images to process, okay? So now we need to, since we're not going to give every single image for the detection, right? We just want to we just want our script to go through the every image that is there and to make the detection. So we have the for loops here. So you're going to have a very large amount of image that is scraped. So you just need to make your script to run through all of the images there. So so for image existing on that specific directory, what we're going to do is we're going to plot the array. So this is telling the model. So here the main thing is here the results here are going to be from the model. There's the image path. Okay, from the image path, we're going to read every image and we're going to pass through the model that we uploaded earlier. So the results for the results, we're going to plot a graph or not a graph. Actually, we're just going to plot something in order to preview or to see the image. Okay, so let's say we've specified a safe path here, which is detected underscore the file name or specific file name that we're going to run, since we need to have a specific name for every detection. And then we are writing or we're saving that specific detected image. So this loop or this part of the code will just save the image. So now, what are we trying to do here is, so for books in our those boxes, so now we already have a box. Let's say we already have the detection. So I will describe this part later, but let's just run this one. So this had we have run this part inside the data. We had deleted image previously. We only had we had deleted the results. We were already dealing with the image part. So now we also have the results, right? So what is the result? Trying to preview the result. The first result is this. So because the first image was this was the first image to be detected. So the detected images are there are the car, there's the remote, uh, and there's the coach inside. Here also there's the cat and the remote is not detected, right? For the second image, there's a person here, there's a traffic light. Oh, there's an umbrella that is detected. I haven't even seen the umbrella. There's the person in the person. So also a chair here. So you can see that this is the bounding box, okay? This is the bounding, the every lines or every boxes that those are called the bounding box. They are drawn by generating some x and y value axis, okay? So the person, the chair, the traffic light, and the umbrella, those are what we call labels or classes. In this number here, the 0.93, 0.37, 0.89 are the confidence score, okay? So you can see that this for sure, this thing here is a person, so it is a large amount of confidence. But the chair, this is not a chair. Also, you can just see that there is a 0.35 confidence score. Mostly, if the confidence score is less than 0.6 or 0.7, you cannot be sure about that specific detection. Also, there's 0.89 and 0.92, so we can be sure 0.52 here. We are not even sure, but it seems like a traffic light, right? So the confidence score is calculated by itself. So we can just put some amount of logic. Specific some logic that if there's confidence score is greater than this number or less than this number, we're not going to accept this prediction or this classification. We can just say that. For the third image, this one is the image. Sorry, it is taking a little bit of time. Yeah, this is the image, and the detection here is detected image 3. Yeah, the person in this case was 0.5955 accuracy. So yeah, this is the detection, and all the three parts are seen here. Okay, so maybe this is what we need to do. Just put your image, I trace it through your image and classify them. So for your specific case, actually, you need to put here. I have a script that will do the same thing, but what makes a difference is here for books in our boxes. Actually, we have also done it here on the notebook. For that specific thing, it is just taking the detection here, okay? Found cat with confidence number 0.89. it found remote, and we can just put the words here. Just I have put this script here, print the detection. If the detection is true, so for box in our dot box, say list stands for the class, conf stands for the confidence score, and so like labeling the model names of the class, we can just print. We have found a card with confidence score of this number. So this is what we are doing here. This is the printed value. So in your case, you need to put this information like the card, the confidence score, and things on your database. So you might want to convert them to a specific type of format, into a CSV or into a JSON file, as I have mentioned earlier in the PPT. So in this case, if we have finished this, so we are doing the same thing for box in boxes, and we are trying to put or to save it in our CSV path. So you can just name, or you can just create a CSV path here called detection.csv. And you can just save your results there, okay? For this case, running the script, I can just delete the detection here. It will just, it is the same code inside the script and inside the notebook is there. So this will specifically create the detection.csv file, or it will rewrite, because that is what you guys are supposed to do, right? You need to rewrite or save the detection that you made earlier into a specific format, so it will be easier for you to add it to your database. So detection completed, and the results are saved to your detection.csv, which are here. So the detection will look like the image file name, which is image one, whatever your image name is going to be. The detected object is card, remote, person, and things like that, and the confidence color is this. So these are the most valuable information that we need, or that we expect from your YOLO detection. So you can just put it in into this format, whatever format that you want, CSV or JSON, so that later it is going to be easier to put it or to load it into your database and to make some transformation to it. Okay. So yeah, mainly this is the it's just an easy concept, and then a simple tool. I guess it's a simple and useful, very powerful tool. So is there anything that you guys have missed, or that you guys have not understood? Do you have it? YOLO by itself cannot remove the background image. Okay, so you will just try to detect whatever thing we have there. But of course, by merging it with another tools that can remove their background, you can create this type of functionality. But YOLO by itself is just for detection and for extracting some information from the image. It is not some form of photoshopping or changing a feature. So it is just a detection. So you can remove the background by integrating it with different background removal or cleaner, or with another tools. Okay, it's achievable. That's not just YOLO by itself. እሺ አዲሱ exactly እሺ ዮሐንስ you can go.
How do you know the script that you use for the YOLO? I didn't understand the script. And also, how do you fine tune this YOLO? You have said we're gonna fine tune it. So
Yes. So the script, okay, we're going to see it. How can you fine tune YOLO? So have you, Johannes, like, don't mute yourself. Okay. You guys have done fine tuning, right? Have you guys have you fine tuned any type of model previously? I mean, in Kifiya, at least in this channel, yeah. So specifically, while fine tuning, you were provided with a model, right? So you're going to do some change, like some change in a sense. You're going to give it a specific large amount of data towards specific domain or a specific area. In this case, you want your model to be to learn more of a medical to be able to detect medical equipments or things like that. Okay, medical related things. So you're going to give it large amount of data for in order to understand. I'm sorry, I just missed the cursor. Okay, mix. Yeah, here. So yeah, in this case, this is your lobate, and we have loaded the model here. So now we're just using this model for detection. It is just a lightweight model, okay? So we're just going to use this model for detection. But in what we're going to do, if we want to fine tune it, we are going to import this model just as we were doing the same thing for different type of models, logistic regression model and other things and other things. Uh, I mean, whatever mechanism that we were trying using to train a model in our data. So we can just consider it as a model here, and we're going to import it, and then we're going to say it. We're going to train it based on the new data that we have for this specific case or um, for the medical equipment case. So. Yeah, in order to do this, what you guys need to understand is you need to understand the structure or the architecture of the model, okay? Because if you remember, if we're going to train a model of mm, maybe like if we, neural networks if different type of machine learning models, right? So if for different type of machine learning models, there are different type of parameters, there are different type of that is if you aim for hyper tuning, okay? So there are different type of hyper parameters and parameters that needs to be tuned. So you might need to understand the architecture of that model. You can, because you can also tune the hyperparameters and the parameters. So mostly, as I've told you, the object detection model or object detection related things are done based on the CNN or convolutional neural networks. YOLO is also done based on that model. So you need to understand how the CNN. You can just go and search for the CNN model. So you need to understand how we can train the CNN model, and you can just consider it for as just other as just a normal model, okay? So for example, we do use like GPT and GPT to any type of GPTs or other models for our chatbot for different type of specific case scenario by just training it in our data, right? So the same thing is you're going to apply here. You use your data, I mean use this model, and you can just fine tune it on the specific domain area that you want. Johannes, is that clear?
Yes, yes, it's clear.
For the script, okay, let me get back here. For the script, it's just an easy step. So we can just start from the notebook. Do you want to see the notebook, or the main part of for the heart is here, okay? So we're just one of the main part actually is just loading the model or bringing the model for into your local or into downloading the model, okay? So after you download your model, it is just an intermediate step, creating the paths and creating the paths for both for the reading the image and creating a path for the results. Here you need to just iterate through the image and give the image each image for the model. So inside the here for the results, we need the model to go through each image path, which is reading from the image directory that is above, okay? So just it is just some simple logic. So saving them, uh, uh, creating a plot, and then here we will just create an image in order to see the detection, and then we will save this creation, I mean this image into our into this specific saving path. So that is what we are doing here. So there's nothing new. If you check the script, it's also the same concept, but in this case, on the notebook we've just printed the labels and the confidence score. But now, for our purpose, we need to save this information into a specific CSV or JSON format or other format, because you guys need them for your database, to load it into your database, or for training, or for any type of thing that is required on your document, I guess. So this is the new thing here. So we have just we're just trying to write these files, which is the confidence score and the labels, into our new CSV file, which is the detection.csv file. That is what we're doing here. Okay. Mm, yeah, I guess. Is that clear? Is the script clear? Johannes, okay.
Yes, yes.
Thank you. So, Gabriel, how do you the system knows that is person or class or other does all features and parameters in the YOLO model by default and confused. So it's a model, right? We have just said like the same thing, the same. We've been training different type of models, right? So they have applied the same thing, the same process, but on a large number of data. They have their own data, which is the Coco data. So they have applied. They took some time. Some effort. They put some effort there, and have built this type of model for image detection. That is the difference thing. The difference between our model and their model. They have a resource, a large amount of data ምናምን እንጂ the concept is the same. We were just building a model and they have just built a model. So እኛ ምንድነው የምናደርገው? Instead of just building a model from scratch, a model that can detect an image, we're just going to take their model and we're going to if it is needed. So like we're just going to take their model and we can just use it for our specific case, for our case. So ስፔሲፊክ ኬዛችን ላይ ስንጠቀመው ይህን ኬዝ ግን ላይክ ሜዲካል ላይ ምናምን ካልሰራልን ከን ጀስት ፋይን ቱኒት ምናምን ግን ደ ሞዴል ባይ ኢትሰልፍ ኢትስ ኦልሬዲ ፕሪ ትሬንድ ሞዴል ነው ሶ ዩ ካን ጀስት ብሪንግ ዳ ሞዴል ላ ፋይን ቱን ማድረግ ደ ሴም ጎስ ፎር ዲፍረንት ታይፕ ኦፍ ኤልኤልኤ ሞዴልስ የምንጠቀምበት ማለት ነው ላይክ እነ ጂፒቲ እነ ጄሚናይን ኤቭሪ ታይፕ ኦፍ ኤልኤልኤ ሞዴልስ that we're using currently from the scratch you're not going to teach them how to understand human language ምናምን የሚለው we're just going to take their model and fine tune ነው የምናደርገው ገብረህይወት is that clear? No, yeah, it's already pre-trained on those objects. Yeah, no, you also had answered for this. What do you mean? Fine tune for better pre-trained. Any other question? I know it's clear, it's easy, it's simple and powerful as I have mentioned earlier. Then if you have any question, you can just mention. So can I consider that if everyone is on the same stage and it is clear for everyone? Thank you. Can we use Oracle instead of Postgres? Oh. So what I'm afraid of is like it's okay for us. For the grader, specifically challenge document to not based on the challenge document, based on the requirement in the challenge document, check documentation. So if she is not going to say any implementation of Postgres, then Postgres Oracle ስላለ እንትን አታረገው ሌላ ነገር በሌላ ነገር ሪፕሌስ ተደርጎ ነው ምናምን ብላ አታልፈውም so I'm afraid of that ግን እሺ also MySQL okay let me just make sure ኑሪዬና ሄኖክ maybe if ኑሪዬና ሄኖክ if this is your Slack name ሁለታችሁ I guess አውርቻችሁ አላውቅም so Slack ላይ መልስላችኋለሁ or ነገ stand up ላይ መልስላችኋለሁ I need to check for this because I'm not sure ግሬደሯ ጃምፕ ታደርግባችኋለች or like እኛም ማስተካከል አለብን grader if you're going to make that let me make sure and I will get back to you on Slack or you can just say hi on Slack or I will just respond on tomorrow stand up. Any other question? If not we can end the session here. Thank you. Okay, thank you everyone for being here then I'll